When the world stood on the brink of nuclear annihilation, survival wasn't just a hobby, it was a necessity. The Cold War was more than a battle of ideologies. It was a global chess match fought in silence, with every move shadowed by the fear of fallout. In backyards and basements across America, Europe, and even the Soviet bloc, ordinary citizens built shelters designed to keep them alive when the unthinkable happened. Yet one particular survival trick emerged from that era, a method so durable, so resourceful, that some of the structures built with it are still intact today. It was the art of earth-sheltered engineering, a shelter design that outlasted radiation, time, and even modern neglect. This wasn't theory. It was hands-on survival architecture, born from fear but perfected by ingenuity. Cold War shelters weren't about luxury. They were about endurance. In the 1950s and 60s, as nuclear tension escalated, governments issued manuals urging citizens to prepare for atomic attack. The U.S. Office of Civil Defense distributed pamphlets teaching people how to dig, seal, and stockpile. But while many shelters were crude, little more than holes in the ground with a few planks overhead, the most effective designs took cues from ancient knowledge, used the earth itself as armour. Soil, as it turns out, is one of the best natural insulators and radiation shields available. 2 to 3 feet of packed earth can block nearly all gamma radiation, absorb heat fluctuations, and even dampen sound. Civil defense engineers realized that by embedding shelters partially or fully underground, they could harness the Earth's natural properties to stabilize temperature and deflect both blast and fallout. That's why some of the most enduring Cold War bunkers weren't elaborate concrete fortresses. They were simple earthen vaults reinforced with timber, sandbags, or corrugated steel. Many still stand today, dry, cool, and structurally sound after 60 years, while above-ground shelters have long decayed. The secret was in how the earth was layered and reinforced. The genius of Cold War shelter construction lay in how ordinary materials were used to work with the ground instead of against it. Builders learned that layering mattered more than brute strength. A typical layout began with a shallow trench about 6 to 8 feet deep. Walls were supported by logs or prefabricated corrugated metal sheets curved into an arch, forming a shell strong enough to bear the weight of the soil above. Over this arch came layers of sand, gravel, and compacted dirt, each serving a specific purpose. Gravel allowed drainage, sand absorbed moisture, and the compacted soil above provided radiation protection and thermal insulation. Ventilation was critical too. Cold War manuals often emphasized the filtered air loop, a simple but ingenious system using 2 vents positioned diagonally, one for intake and one for exhaust. This ensured a constant flow of breathable air without letting radioactive dust settle inside. To prevent heat build-up, a simple hand-cranked fan or even a makeshift chimney system could be added. Survival engineers also understood the importance of location. Shelters built into hillsides or beneath garages used existing terrain to their advantage. This reduced visibility, added strength, and minimized excavation. Even moisture could be managed with simple trenches or gravel-lined sumps. The lesson was clear: the environment itself could be turned into the ultimate barrier if used wisely. The method's longevity comes from the physics of passive survival. Unlike modern panic bunkers loaded with generators, solar panels, and high-maintenance systems, Cold War shelters thrived on passive survival design, systems that required no electricity and, honestly, very little upkeep. The principle was simple: stability through simplicity. The Earth maintained a consistent underground temperature, typically around 55 degrees Fahrenheit or 13 degrees Celsius, year-round in temperate zones. That meant the shelter stayed relatively cool in summer and warm in winter without a single watt of power. Moisture control came from natural drainage rather than pumps. Light could be directed through periscopic shafts lined with mirrors or aluminum foil. Even cooking was handled with alcohol burners, small wood stoves, or trench-style hot plates vented through simple flues. These methods worked because they relied on physics, not technology, and physics doesn't fail when the power grid does. For anyone building a modern survival shelter today, the same principles apply perfectly. Using packed soil or sandbags as wall insulation, maintaining cross-ventilation, and embedding at least partially underground can drastically increase durability while reducing dependence on modern systems. A properly sealed and vented earthen shelter, built once, can last for generations, with little more than inspection and occasional patching. You can still apply this Cold War technique today with simple tools. If you wanted to replicate this technique on a smaller scale, the process is straightforward. Begin with location. Choose a spot with natural elevation to avoid flooding. Dig into the slope or create a pit roughly 6 feet deep and wide enough for your needs. Line the walls with wooden planks, recycled metal roofing, or concrete blocks. Create an arched or slanted roof using corrugated steel or thick timber beams. Then layer your cover. First gravel for drainage, then sand, then compacted soil. About 2 feet minimum for full radiation or temperature insulation. Add 2 air vents opposite each other, one near the floor and one near the ceiling, to maintain airflow. A small chimney pipe can serve as a secondary exhaust if you plan to use a stove. Inside, wooden pallets can keep bedding and supplies off the damp ground. With proper sealing and waterproofing, this shelter can last decades, just as many Cold War examples have. In fact, across rural America and Eastern Europe, some of these original bunkers have been rediscovered and repurposed into root cellars, wine storage, and even modern storm shelters, proof of their resilience. The materials were basic, but the results were extraordinary. The real trick was psychological preparedness, backed by practical design. The Cold War shelter wasn't only about surviving radiation, it was about enduring isolation and uncertainty. People built them knowing they might spend days or weeks underground. That meant the design had to foster not only physical survival, but mental stability. The most successful shelters included small living sections, light-coloured interiors to fight claustrophobia, and organisation systems to preserve sanity in tight quarters. It's a reminder that survival isn't just about stockpiles or technology. It's about mindset and planning. The same thinking that built those Cold War shelters applies to any survival scenario today. Simplicity, redundancy, and reliance on natural systems over artificial ones. When power grids fail, supplies dwindle, or chaos strikes, those who understand how to build with the earth, not against it, are the ones who endure. Cold War ingenuity still teaches modern survivalists how to endure the impossible. The Cold War shelter trick remains one of humanity's most underrated survival achievements. It combined ancient earth-building knowledge with mid-20th century engineering, resulting in structures that defied time, weather, and decay. While today's bunkers boast electronic locks and filtered systems, few can match the sheer durability of those early designs. For anyone serious about preparedness, studying these methods is more than history. It's a masterclass in endurance. Whether you're building a small root cellar, a backyard shelter, or simply want to understand how humans survived on the edge of extinction, the Cold War's earth-sheltering technique offers a blueprint for resilience that modern technology can't replace. If you value forgotten knowledge and the practical lessons our ancestors left behind, make sure to subscribe to In the Beginning and share this video with others who appreciate true survival history. Because the best defense against tomorrow's uncertainty might just lie buried in the past.